Welcome to my talk. It is titled Assessing Needs for Cognitive Assistance with a Cognitive Constraints Approach. During the next 10 minutes, I will try to give you an impression of the study we did, its theoretical background, and its practical value. Cognitive assistance plays a major role in smart working environments. Smart factories demand a well-qualified workforce able to master complex work. The availability of large amounts of information in real time and task discretion need to be paralleled by appropriate skills like data literacy, abstract thinking, and problem solving. Conceptions of smart factories therefore envisage a prominent role for digital assistance systems, but suggestions on how to are still rather vague or simply technology-driven. What we need is cognitive assistance that is based on real task demands. The methodology of cognitive work analysis, in short CWA, is a framework to analyze complex socio-technical systems on multiple levels. In CWA, so-called constraints shape the way work is conducted in a certain domain. Constraints concerning human cognition are still not well established in CWA, and there are further limitations to CWA in the field. Its methodological complexity and scarce resources hinder a broad application. We need methods of task analysis and guidelines for job design that can be mastered by many people in the Industry 4.0. In other words, we need something like industrial cognitive engineering. In order to accomplish this, we need a model of human cognition and its limitations. Human cognition is, of course, a complicated matter. So what we need is a simplified model that is just complex enough to be useful. Such models have been put forward before, notably by psychologists like Jens Rasmussen, David Kahneman, and Winfried Hacker in Germany. Our model draws on those models, but integrates findings on cognitive limits from the literature. Human cognition is depicted as a system with output-input relations to an environment. On the basic level, we have perception, thinking, memory, and action as various cognitive processes. On a higher level, we have attention and executive control as regulative processes acting on perception and thinking. We also have a rapid action device by linking directly perception and action. These processes are now limited in three major ways: capacity, speed, and reliability. The graph shows which processes are limited in which way. Of course, that's not all there is to say, but it probably covers a good deal of limitations and is broadly applicable to various tasks and domains. So now the idea is to test the model. We did a qualitative study with job holders from different sectors. The principal idea is to ask job holders in different sectors which constraints they experience in their daily work. If the model is valid, the limits should be addressed by the job holders. So we set up a number of questions in a semi-structured interview setting. If constraints are experienced, we also asked for ideas for cognitive support. The table depicted shows the domains of work addressed and the respective number of interviews with a total of 20 interviews. We analyzed the answers with a standard method of qualitative research, the content analysis according to Meiring. We used two main categories which we set up a priori and a number of subcategories, partly a priori and partly derived from the material. Overall, the concept did work. Our subjects understood the questions, related them to their work, and answered in a meaningful way. As we can see, two categories of constraints stand out: reliability and speed. Reliability means there is an awful lot you have to keep in mind and remember. Speed means task pressure and multitasking exceeds often the speed of processing of the human mind. Besides that, they mentioned a considerable number of information-related soft spots, weaknesses in infrastructure and process design and management. With regard to wishes for assistance, we see both categories widely used, but with delegation of cognitive steps even stronger. So we can differentiate at least two different levels of desired assistance. So, overall, the approach is valid. Asking job holders about constraints experienced gives meaningful answers that can be used in selecting or designing means of assistance. Furthermore, we derived an initial and still tentative taxonomy of cognitive assistance from the answers of our participants. With taxonomy, we mean a systematic order of means and ways of assistance. The taxonomy is constructed around two dimensions. First dimension, the degree of support shown vertically. It goes from mere presentation of information over filtering and visualization of information to executive control, meaning some kind of automation of cognition. Second dimension, the source of data. Structured data comprises all formatted data, that means numbers. Unstructured data contains texts and pictures. Machine learning models provide information based upon some statistical procedure on the data. For both dimensions, the effort of designing such a means increases from bottom to top and from left to right. A 4x3 matrix gives 12 fields, with 9 fields being interpretable. We can further summarize the various types of cognitive assistance into 4 groups, here indicated by color. Level 1 to level 4. What is such a taxonomy good for? If you access needs with the approach presented here, you might wish to proceed by searching for the appropriate means. You will try to make this decision not only correct, but also cost efficient. That means not more complex than necessary. This taxonomy can support the discussion and the decision based on complexity needed and type of data available. Last but not least, what are the limits of our study? We have a small sample size and we have qualitative design. Certainly, the range of sectors and occupations under investigation needs further enlargement. We can also hint to some interesting directions for future research. The medical sector would be a promising candidate due to the high complexity of its processes. It might be rewarding to check for commonalities with the functional resonance analysis method FRAM, and we might wish at some point to include individual differences with regard to more specific objectives of analysis. Thank you very much for your attention.